This is a video from section 1.3 in a linear algebra class. We're going to look at matrix multiplication using a different method called column-row expansion. Suppose A is an m by q matrix and B is a q by n matrix. AB is defined and the dimension or size of AB is m by n. Let C1, C2 through CQ be the columns of A, and let R1, R2 through RQ be the rows of B. AB is then equal to C1, R1 plus C2, R2 plus all the way through until CQ, RQ. Now, I want to give you an example of how this works. Let's take a look at this example. Let A equal the matrix 1, 2, 3, 4, and B equal the matrix 1, 2, 3, 4, 5, 6. So notice that A is a 2 by 2 matrix, and B is a 2 by 3 matrix. And so AB will then be a 2 by 3 matrix. Okay? Now, let's take a look at AB. Now, I'm going to write the matrix 1, 3 times the matrix 1, 2, 3. So notice, the matrix 1, 3 corresponds to the first column of A. The matrix 1, 2, 3 corresponds to the first row of B. Then I'm going to go plus, and then I'm going to write the matrix 2, 4 times the matrix 4, 5, 6. Now notice, the matrix 2, 4 corresponds to the second column of A. The matrix 4, 5, 6 corresponds to the second row of B. And now, let's take a look. So the matrix 1, 3 is 2 by 1. The matrix 1, 2, 3 is 1 by 3. So when I multiply those two matrices, I should get a 2 by 3 matrix. And same thing here, right? The matrix 2, 4 is 2 by 1. The matrix 4, 5, 6 is 1 by 3. So the result should be then a 2 by 3. Now, we're going to do a little matrix multiplication. And so to get the first row of the product, I'm going to take 1 times every single one of these entries in the matrix 1, 2, 3. And so when I do that, I get 1, 2, 3. Now, to get the second row, I'm going to take 3 times every single entry. And when I do that, I get 3, 6, 9. Then I go plus. Now, to get the product, right, for this second matrix, I'm going to take 2 times every single entry in the second matrix. So 2 times 4 is 8. And remember, I'm getting the first row. 2 times 5 is 10. And then 2 times 6 is 12. To get the second row, I'm going to take 4 times 4 is 16. 4 times 5 is 20. And then 4 times 6 is 24. And then all I have to do is add up the corresponding entries to get the sum. So 1 plus 8 is 9. 2 plus 10 is 12. 3 plus 12 is 15. And then 3 plus 16 is 19. 6 plus 20 is 26. And then 9 plus 24 is 33. And that's how we do example 1. It's a really, really slick way to do matrix multiplication, I must say. Let's take a look at another example. We'll do example 2. Suppose A is the matrix 1, 2, 3, 4, 5, 6, just like this. And so notice that this is a 3 by 2 matrix, right? 3 rows, 2 columns. And so I'm going to say B is the matrix, we'll say 4, 5, 6, 7, 8, 9. So notice that B is 2 by 3. So my result should be a 3 by 3 matrix. Now, I'm going to take AB. Now, we're going to write the matrix 1, 3, 5. Okay? So notice how the matrix 1, 3, 5, that can also be viewed as a column vector, by the way. So we're going to take 1, 3, 5, and that's the first column of that matrix corresponds to the first column of A. And we're going to multiply by the matrix 4, 5, 6. Okay? Then I'm going to go plus. Then I'm going to take 2, 4, 6. Notice how that matrix corresponds to the second column of A times 7, 8, 9. Now, we're going to look at the first product. To get the first row, I'm going to take the entry 1 times the 4, the 5, and the 6. That's going to give me the first row. So I get 4, 5, 6. Okay? Then I'm going to take 3 times 4 to get 12. This is going to produce the second row. 3 times 5 is 15. And 3 times 6 is 18. Then I'm going to do 5 times 4. That gives me 20. Notice I'm going for the third row. 5 times 5 is 25. And 5 times 6 is 30. Then I go plus. And then I'm going to do the same thing for the second product. And we'll leave this alone for the minute, right? And then 2 times 7 is 14. 2 times 8 is 16. 2 times 9 is 18. 4 times 7 is 28. 4 times 8 is 32. 4 times 9 is 36. 6 times 7, right? I'm going for the third row now, is 42. And then we get 48, right? That's 6 times 8. And then 6 times 9 is 54. Now, all we have to do is add up those matrices, and we have found the product AB. And it's really, really very slick. Now, so therefore, AB equals, so notice, 4 plus 14 is 18. 5 plus 16 is 21, and 6 plus 18 is 24. So it's 18, 21, 24. That's the first row. Let's do the second row. 12 plus 28 is 40. 15 plus 32 is 47, right? So it's 40, 47, and then 54. That's the second row. Third row, I'm going to get 62. That's 20 plus 42. So let's write that one first. So I'm going to do 62. And then 25 plus 48 is 73. And then 84. And we just looked at the product A times B. That'll do it for this video. This is a good stopping point. So this is section 1.3 in a linear algebra class. We looked at matrix multiplication utilizing the column row expansion. Okay, thank you.